Hello everyone. This is the video lecture for Pre-Calculus 4.1. We're doing exponentials. And so, let's get right to it. What is an exponential? Well, it's something kind of like y is equal to b to the x. B is your base. And so, as some examples, we got y is equal to 2 to the x, y is equal to 5 to the x, y is equal to e to the x, and e again is a constant, about 2.71828, da 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 da. It's kind of like pi, it goes on forever. We'll see this again a lot more throughout chapter 4, but for right now, it's just a number, and we'll use it occasionally here in this section. Anyways, so what does the graph of an exponential function look like? It looks like that. Exponential growth. And we also have something you probably don't think of every time, exponential decay. So that is decay. And they're useful in the real world. Growth, of course, well, there's a lot of like population growth, growth of bacterias, and all kind of different things. And we got decay is radioactive material or drugs in the bloodstream or all kind of different stuff. So real world application. Now, let's get to the actual question. So I got 4, 1, 3. The first question is 2 to the power of the square root of 5. What is it? And they say use a calculator, and that's good because, well, I can't do that otherwise. So 4.711113. I don't know how far they want you to go, but I'm just going to give you a whole lot of decimals, and you can cut it down to whatever they want. Okay, that's supposed to not be a 17. That is a 1-7. But either way, it says find e to the 1.6 in the calculator. So I use Desmos Scientific for all of this. The reason why is because, well, it's free. It's easy. You should be using it for pretty much everything around here. So Desmos Scientific, totally recommend doing all this stuff here. These first questions in my math lab are asking, hey, do you have a calculator available that can do this kind of stuff? Not just a for function, but, you know, something else, a scientific that's capable. And the answer is yes, because you're using Desmos Scientific, right? So Desmos Scientific, that's totally what I recommend. Moving on, 4, 1, 11. It says that f of x is equal to 4 to the x power, and they want you to fill in this table. Now, again, I would use Desmos Scientific for all this stuff. It is so easy, but they want you to fill in all these values here. I'm going to do this by hand, kind of. So what is 4 to the 0? Well, anything to the 0 power is a 1. What's 4 to the 1 power? It's 4. What's 4 squared is 16. And so with these, if you go backwards to like negatives, it's the same thing. It's not a 4 though, it's a 1/4. Instead of a 16 is a 1/16. And that's what they're wanting in my math lab. So not too hard there, pretty easy. After that, they want I'm trying to make that x look better, but it's whatever. They're saying, hey, what's the graph look like? Well, it looks like this. Now, all the graphs in my math lab are really similar. One of the things is that you have to look out for here is that at 0, you're looking at a height of 1. I mean, it's same as the table here. And at 1, you're looking for a height of 4. And if you get the function, the graph that looks like that, then you got it. All the other options kind of look like that, but you just got to look out for the points and stuff. So, in Desmos Scientific, in order to do this like really quickly, there's like a line for each like expression in Desmos Scientific, and I would put 4 power x and make it look like that. And what happens is immediately it has like a triangle saying, hey, you can't do that. The next line, it says something, you put something like x equals -2, and then this triangle will change. I'm going to try to show you a change in my triangle here. I don't have a good eraser function, so I'm just drawing white all over it. So there you go. Okay. And so it would then say, oh, you mean, and there's like some decimal. I would say that there's like the fraction button right here that you click to make it into a fraction. I can't remember what the decimal is exactly, but the point is that you would get the value here, after you put in your x. And then you could just change this to like a -1 to a 0, and it changes that number as you keep going. Very cool, very easy, very quick. And so that's what I recommend. That's the most scientific. Super, super awesome to use. Okay, next one is graphing, matching kind of thing. So this is technically 19 through 24. So there's a lot of different graphs, and they're wanting you to match it up. I'm just going to give you what they are and then just graph it and tell you why and all that kind of stuff. So we start with 6 to the x. Again, they're going to have 6 of these kind of like laid out on the homework. You just need to start with this one. Find this guy first, okay? So this is the basic one, and it's the easy one. What does it look like? It looks like this. But now we're looking for specifics. Remember that it's crossing here at 1, and then at 1, you're crossing at 6. So that's that same base right there. If you get this guy, then you're going to take this one and manipulate it for the others, okay? So that's like your normal, regular base, whatever it is, okay? So then the next one would be x, 6 to the x, and then -1, like down here, like a big -1. Well, this -1 means that you're going down, and so you're looking for the graph that looks just like the original, but that it's been shifted down by 1, which now makes it go through the origin, by the way. So next one, we have -x, or -6 to the x. That negative in the front flips it vertically. So it's basically upside down. My original looked like this, and now it looks like this. So you're looking for the original that's simply just flipped upside down. I have 6 to the x -1. Notice that it's all up in the power there. So inside opposites, this is actually going to the right. And so I'm going to take my original, looks something kind of like this. I'm going to go to the right by 1. It's kind of hard to tell this one versus some other ones, especially these two right here look kind of similar. Just watch out. Note that like you're going to be at 2, 6 now, that kind of thing. So just be careful with it. We got another one is 6 to the -x. So now we're flipping it, but we're flipping it side to side. So this is my original, and so now it looks something like that. And then finally, we have -6 to the -x, 2 negatives, 2 flips. And so my original looks like this, and then I'm going to flip it upside down, and then I'm going to flip it again. There you go, 2 flips. Cool. Next question. For 153, trying to make them 3's look good. So I got A is equal to P times 1 plus R over N all to the NT. And they also have, like as another formula, A is equal to P times E to the RT, the PERT formula. This is compound interest. Compound interest. I know my handwriting is not the best, but that's why I say it out loud. So, compound interest, they have some questions on this. I think it's not just this question, but a few other ones. But this is the basic one. This is the first one. It's kind of simple. We have an investment of $10,000. I'm going to try to do that. That's not a really good dollar sign, honestly. Well, it doesn't really matter in the end. You know I just said dollar sign. Dollar sign, $10,000. So we had $10,000 just laying around. And they say, hey, you're going to put it into a bank for 5 years. Okay. There is a rate of 6.5%. There we go. Which I'm going to just tell you before we keep going that you definitely have to convert that over into decimal form. So that's something we're going to have to see. And then they're going to give you, like, they don't give you N, but they give you some words that reflect what N is going to be. So this guy is going to be your P. This is your T time. This is your rate, R. And then A, it says semi-annually. And so what they're trying to say here is that N is equal to 2. And so the other ones are quarterly is 4, monthly is 12, etc. So I'm going to just choose the formula right here because we have all those values. This one here is for continuous, which I'll show you here in just a second. So they want to find the final amount, and you just plug it all in, and you get an answer. So 10,000 times 1 plus, my rate is 0.065 all over 2 to the 2 times 5. And I put this all into Desmos Scientific and get an answer. Now, I am just going to give you that answer right quick. I don't have all the answers here on my notes because, honestly, it's just a repeated thing again and again. There we go. So there's my final dollar amount when I put that all in. Some common mistakes that you could have as you're going here is that this thing here in Desmos doesn't look good. It might drop the 5 down, so it's like times 5. What I do is I try to keep the whole thing in parentheses and put a time sign between them. There's a lot of options with that. Or you could just say, oh, well, I know that's 10, and I recommend doing that. That's super easy to do. So just watch out. If you're not getting this, that's one of the key ones that gets missed, is this 5 drops down because Desmos just does that, I guess. I don't know. So that was part A, and there's a whole lot of different parts. Part B now says, let's do it quarterly. So how many quarters are in a year? It's 4. And so you just do the same thing, just with n equals 4. Part C, it says, hey, now we want to do it monthly. And how many months are there in a year? There's 12. And so then you do the same formula. Just put a 12 in right there and right there instead. And then part D finally says continuously. Continuously. And so technically n equals infinity, but that's not really something we can plug into a calculator. And therefore, we use that special formula, the PERT formula. I say PERT because it, PERT looks like it. But really, the formula is very simple. You just put 10,000 E, and then you put your 0.065 times 5 in the power, and you get an answer. So you go right in, put all this into Desmos Scientific, 13,840.31. And I do believe they want you to do 2 decimal places for like dollars and cents and stuff. So do stay on top of that. And there you go. Pretty simple, pretty straightforward, honestly. Let's do another question or two about this. So I've got 4155. They have $13,000 to invest. And they say we have 5 years. It's kind of similar to what we had just a second ago. We have 2 different banks in this particular problem, and they want to compare them. So Bank A has a rate that is 7% daily. How many days are in a year? Yep, 365. Very good. And then we have Bank B. It says that it has a 6.94%, but this time continuously. And again, that's just using the PERT formula. So which bank is better in the end? So I split it up into Bank A and Bank B, and we just do the formulas. So 13,000, 1 plus. My rate for Bank A is that 7%. Daily is 365. And then 365 again, all to the 5. So that's... It seems like, wow, that's going to be a big number. But honestly, when you put it all in, it's going to not be that much bigger than this guy. I mean, it might be smaller even. I don't know. The Power 365 stuff, it honestly is not that big of a deal. So let's do the other one, the continuously. So I have 13,000 E to the 0.0694. Notice I'm converting these into decimal form. And then times 5. When you put this all together, you get a different answer. So let me give you the answers again. I'm not actually showing you that stuff. I don't really do that on my videos, but I do tell you, hey, I'm using Desmos Scientific. So you know what I'm doing, and I'm figuring that you can, type that stuff in without having to see me do it. And there you go. So those are the 2 results. This one's better And so I would say bank A is better. And that's the end of that problem. Now, because it's multiple choice, couldn't you just keep on clicking the first one until you get it right? I don't know. Um, no way. No way, Chad. We're not doing that. So we have another problem here. So this one has a graph where I have 2 points at 0, 1, and I have another point over here at 1 and then 1/5. So that's a 1/5 right there. And they say y is equal to what? Give me what the exponential graph function stuff is. Well, I'm going to tell you that exponential, it would be b to the x. And I'm simply solving for b. If you know how this works, at 1, you're going to have your base. Like, we're done here. Literally, done. So in parentheses, keep the 1/5 and then to the x power so that it looks just like that. There's your answer. If you want to go a little bit more, I don't know, plug it in method maybe, we have y is equal b to the x. And I'm just going to pick this point because it's an awesome point here. I have my y value is a 1/5, and I have a b, which I don't know, but my x is a 1. And yeah, we just solved. And you can plug in any point and eventually solve. That's just the easiest way to do it. So there you go. No problems there. The next problem is kind of like a word problem. Well, it is a word problem. And so there's a lot going on. Lots of words, lots of talking, lots of terms. And so I'll just give you the quick version. They have a function f of x, and they say that this is a linear model. And it is, because it's kind of like mx plus b. That means line, linear. See the line in there? The other one is an exponential model, and they say it's 32.9 e to the 0.0218 x. This is exponential. I'm going to try to make that look a little bit better. There you go, exponential model. They say that x is years after 1980. There we go. There, that's better. And we're looking right now in the year 2010. Okay, well, if that's the case, what's x equal to here? It's 30. Very good, very good. So x equals 30, and they want to compare these two models. So they say, what's going on with the linear model? So I put in x equals 30 and plug it in, and then we're done. That was it. So 56. Yay! Now, I believe that this is like a percentage or something. It's not that big of a deal. Just your answer is 56. So then they say, hey, what's the exponential model look like? In that tone of voice, by the way, it's totally normal. And so E 0.0218, and then X here is a 30. When you put this all into the calculator, because, well, you need to, and I got 63.27388. Again, you can like cut it down to whatever decimal places they say. That's up to you. That's what you do. I'm just giving you the full thing here. Cool. Part C. They say compare with the bar graph that we had above and all that kind of stuff. Well, there was a bar graph on this problem, and it looks something kind of like this. And here in 2010, they have a 61 up here. Again, I think it's a percent. So they're saying, hey, which one is closer? Well, it's this guy that's closer, right? Notice that 63 is really close to 61. And they might even ask, so how much like apart are they? Does it overestimate or underestimate by how much and all that? You just subtract them if they ask that. But I'm not really worried about it, and neither should you be worried. So, next one. I have 4173. I actually kind of like this problem. It's a fun little word problem. Okay, so I have 90 e to the negative 0.6x plus 10. They give you this formula, and they say that this is the percentage of information remembered by somebody X weeks after they learn it. Okay. So I'm not going to go through the whole spiel here. It's actually a pretty straightforward problem. But in class, I kind of make it like a joke, a running joke and stuff. I'm not going to do that here. We're just doing the math, so that's fine. They say, hey, what's going on at week 0 or as soon as you first learn it or something like that. So you plug in a 0, and yeah, guess what? It's 100%, so good job. So 100% of people can recite what they just learned. So that was easy. X equals 1. And so then after 1 week, what do? Well, we plug it in. So 90 e to the negative 0.6 times 1, and then plus the 10. Pretty simple and straightforward. We got 59.393. Well, that's a lot of people forgetting stuff already. Wow. Makes me wonder. So C, they say now what's after 4 weeks? Just do the same thing. And then finally, they say, what's going on after a year? Well, how many weeks do we have in a year is 52. And so I plug in the 52, and blah, 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 blah. It's 10%. And that's it. You could go and do the Desmo scientific thing, but I'm going to just tell you, if you look right here, that's your 10, honestly. It's pretty straightforward. It's an easy problem. Okay, and I actually have just one more, and then we're done with the section, so that's kind of nice. So this is a logistic growth model, and let me give you the formula first. They got capital N of T is equal to 50,000 all divided by 1 plus 30. Let me make that look a little bit better there. 30. E, my E's are more looking like C's. Negative 2.0 T. I know my point didn't come out super awesome. And they say that N is the number of people sick with a virus. Oh, awesome, man. That's totally what I wanted to do. So I'm just going to say people. There you go. Close enough. So part A, it says how many folks are initially sick. So initial. What are we talking with time-wise? Gosh, that doesn't look like initial. It's initial. I had to tell you. What's my time at initial is t equals 0. When you plug that in to this big formula here, again, you're just plugging that t in right there. Very simple. And you get a 1613 people. Okay. I think I rounded up. I got a 1612.9. And so just round, I guess. They said second week. And I'm guessing that t is in weeks because that's what I just did. T equals 2. I plug it in. I mean, this is all just plug it in kind of problems. 3, 2, 2, 6, 9. Again, people. And then C, it says, what's the limiting size? The limiting size. So if you look at the numerator, I could just show it to you here. If you look at the numerator, that's your limiting size right there. Very simple. There's no math involved. So there you go, 50,000, and we're done with that problem. I'm trying to remember. I don't think that this problem actually looks like this exactly. It's kind of broken up or split into 2 different problems or something like that. But I'm just giving you the basics here of what to look for and how to do it. Just plug it in. That's all I got. Thank you very much. Have a great day.